In this video, we are going to learn step-by-step method of solving mass balancing using analytical method. The question says the four masses A, B, C, and D are 100 kg, 150 kg, 120 kg, and 130 kg attached to a shaft and revolve in the same plane. The corresponding radii of rotation are 22.5 cm, 17.5 cm, 25 cm, and 30 cm, and angles measured from A are 45 degrees, 120 degrees, and 255 degrees. Find the position and magnitude of the balancing mass if the radius of rotation is 60 cm. So the first thing is to write out the given data. So we have the mass given below, we have the radius, then we have the centrifugal force, which is the product of mass and radius. So then we have the angle. Since all the angles were measured from point A, it means that our reference point is at point A. So theta A is equal to 0. So you have theta B as 45 degrees, theta C is 120 degrees, theta D is 255 degrees. Then the theta is the position of the balancing mass. So the second step is to draw space diagram or angular position of the masses. So since our reference point is point A, so we start from A. So we have the mass, and the radius. So the angle from point A to point B is 45 degrees, and the radius is 17.5 cm. The angular position from point A to point C is 120 degrees. You have the radius as 25 cm. The angular position from point D to point A is 255 degrees. Then the radius is 30 cm. So after drawing the space diagram, the next step is to resolve the forces horizontally and vertically. So we have, we resolve horizontally. So summation of all the forces cos theta is equals to MARA cos theta A plus MBRB cos theta B plus MCRC cos theta C plus MDRD cos theta D. So we've already calculated the forces, which is product of mass and radius. So we have 22.5 cos 0 plus 26.25 cos 45 degrees plus 30 cos 120 degrees plus 39 cos 255 degrees. So here we have when you punch it in your calculator, you have these values. So summation of all these values will give you 15.97 kilogram meters. So you repeat the same process for the vertical component, which is the summation of the forces sin theta is equals to MARA sin theta A plus MBRB sin theta B plus MCRC sin theta C plus MDRD sin theta D. So when you put on all the values, you have this. So at the end of the day, when you punch it in your calculator, you have 6.87 kilogram meters. So step 4 is to determine the resultant force. So and the resultant force is square root of summation of horizontal force squared plus summation of vertical forces squared. So you have root 15.97 squared plus 6.87 squared, which will give you 17.39 kilogram meters. That is the resultant force. So step 5 is equating the balancing force to resultant force. So the resultant force is equals to balancing mass times radius, but they are in opposite direction. So you have 17.39 kilogram meters is equals to mass times 0.6. So when you make the balancing mass of the formula, you have 17.39 over 0.6, which will give you 28.98 kilogram. So step 6 is to determine the position of the balancing mass. So we have that tan theta is equals to vertical component over horizontal component. So we have summation of the vertical forces over horizontal forces, so which will give you 6.87 over 15.98, which is 0.302. Then tan is equals to theta is equals to tan inverse of 0.4302, which is 23.28 square. But since the balancing mass is equal and opposite to the resultant force, so we have that theta is equals to 180 plus 23.28, which will now give you 203.28 degrees. Thanks for watching.